All right, let's take a look at solving this system of equations. We have three variables, three unknowns, and the system is written in such a way that it's going to be easy for us to do elimination. Notice the x's are in a column, the y's are in a column, and the z's are in a column, and the constants are on the other side of the equation. So label your equations 1, 2, and 3. Make a decision of which variable that you want to eliminate. There's no wrong decision. Sometimes there's an easier path to arrive at the problem. So to me, immediately the z's pop out that I have a positive 4 and a negative 4, and I can easily change this to a positive 4 by multiplying everybody by 4 as well. And the x's wouldn't be really any of them would be fine as a choice. You love seeing the coefficients of 1 in front of there, because then that can be your pivot, and use it with the other equations to eliminate the variable. So let's eliminate z. And I'm first just simply going to add equations 1 and 3. Try to make sure that you copy the problem down correctly and that you don't accidentally jump and continue to another line. It's sometimes beneficial for some students to also put coefficients of 1 in front of there. Alright, so if we add these two equations together, the resulting equation does not have the variable z. That z has been eliminated. And we can number this equation 4. So we used equation 1 and equation 3 to eliminate z. We need to now use equation 2. And it doesn't matter if we use 2 with the equation 2 with 1 or equation 2 with 3. So I'm going to use it with equation 3. What I'm going to do is still eliminate z. And I'm going to take 4 times equation 2. And then add to that equation 3. Now, by multiplying this by 4, I can see that I'm going to get a positive 4z, and I can also see in equation 3 that I have a negative 4z, and z will be eliminated. So if I multiply this by 4, is that 70? I better check that. Yeah. Alright, number 3, or equation 3. So if I add these equations together, I just go along column by column, and I get a 2x and 11y. The z's are canceled, and 72. So, oftentimes because of my poor arithmetic skills, I do look to see if there's a common factor that I can divide every term by just to get the size of the number smaller, but this time I don't see that. Alright, and plus with the calculator I'll be fine with the larger numbers. So now let's take our two equations and move it to the other page to where we have some room to talk about it. So let's come over here, make that a little bit bigger. That was my equation 4. And take this. Alright, so now I have another decision to make. Do I want to eliminate the x's or eliminate the y's in this 2 by 2 system? Well, I could eliminate the y's, but it would be much easier to eliminate the x's. So if I eliminate the x variables, I'm going to take equation 5 and add to it 2 times equation 4. Because I have a positive 2x here, and when I multiply this equation by 2, I'll have a negative 2x, and positive 2x and negative 2x will cancel. So I have my equation 5, and 2 times equation 4, and every don't forget to multiply a term by 2. Every term gets multiplied by 2. So the x's are eliminated, which is what we wanted. 11 minus 6, 5. 72 minus 42, 30. Divide each side by 5. And I have my first of 3 answers. I want to get a value for x, y, and z. So I can now, return to the immediate pair of equations above there and use either one, use equation 4 or equation 5 to solve for x. Let's shrink this up a little bit. And I'm just going to plug it into equation 4. So equation 4 has the opposite of x minus 3 times y. But we just discovered that y was equal to 6, so we can substitute. We replace the variable y with its known value of 6. Alright, so let's solve for x. Let's add 18 to each side and take the opposite of each side. And now we have 2 of our 3 variables. So we need to return to our original system of equations and look at the original variables. They were the only ones that had all 3. Let's paste it over here. Alright, and it doesn't matter which of these we use. I just usually scan and see if there's an easy choice. Like if I'm solving for z, I just may as well use equation number 2 there. So if I use equation 2, and this was equation 4, but we substituted in for y. So equation 2 has x, but we know x to be 3. 3 plus 3 times y, but we know y to be 6, plus z is equal to 19. So we've got 3 times 6 is 18, plus 3 is 21. And if you subtract 21 from each side, you can see that you'd have to take 2 away from 21 to get to 19. Now, when we present our final answer, you present it as an ordered triple, and typically it'll be the x coordinate first, the y coordinate first, and z. That's kind of the standard. However, if you wrote whatever order that we write these here, I would accept it if you had the corresponding correct order over here for the values. So the x value is coming first, then the y value, and then this. Because every once in a while you have letters that are variables that are different than x, y, and z. You have a, b, and c, and there's not a true standard convention when you start having other variables. The x, y, z is a pretty standard convention. Alright, so let's move on to the second problem here. We have a system of equations. We have 2 variables, 2 unknowns, but this time, see, last time all of our variables, all of the variables had an exponent of 1. This was a linear system of equations. And this time we have a second degree on this x term. That's a quadratic equation. Now, this equation number 2, that's a line, that's linear. So what we suspect is that we're going to have a parabola, and it's likely that this line is going to intersect that parabola. If it doesn't, it'll be no solution, but it's likely to intersect it in two places. We want to find the coordinates of each of those points. This point will have a coordinate pair x comma y. This point will have an ordered pair x comma y. And one of the mistakes that students have made is they only give you part of the answer. Now, in the first problem, we did elimination, but we won't be able to eliminate a squared term. So on this type of equation, when we have a quadratic and a linear, we're going to use substitution. Now, it's set up perfect the way it is right now because we can look at equation 1, but instead of writing the y variable down below it tells us that y is equivalent to x minus 2. So I'm going to substitute my equation 2 into equation 1. So on the left hand side, instead of writing y, I can replace it with x minus 2. Well, now you have an equation that you're pretty familiar with. You've seen this in multiple classes. You know, you see it in algebra 1, algebra 2, and you even see it in geometry. So we can solve quadratic equations by several different methods. The king of the methods, the one that will always work, is the quadratic formula. But sometimes some of these equations you can factor them. And a lot of times the factoring will just be a faster solution. You could also complete the square. Let's get this in a standard form, which means that we'll have 0 on one side and descending order on the exponents on the other. So now if you prefer to write the minus x right below it and minus x right, if you need that visual aid, then go ahead and do that. What I just do is if a term changes sides, it changes sign. So I know this 1x, if I move it to the other side, is going to become a negative 1x. So I look at this and I only see one term that has an x squared. I see two terms that have an x. And when I move them to the same side, to the right-hand side of the equation, I'll have negative 6 and a negative 1 for a total of negative 7 of these x's. Now, I have a constant term on the left, and I have a constant term on the right. If I add positive 2 to each side of the equation, I'll get 10. Now, factoring is much easier when that leading coefficient is 1, because, you know, you can still draw your x if you'd like, but this time when you find the coefficients in front of here, they're going to be your factors over here. And many times people can just, after so many times of writing that x out, they can just kind of visualize it in their head and say, I'm looking for two numbers that when multiplied together give me this 10, but yet when added give me the negative 7. Well, since the middle term is negative, then we know we're going to have at least one negative number, but since that term is positive, it's got to be a negative number times a negative number. And 10 only has factored, we can only get 10 by 1 times 10 or 2 times 5. And the 2 times 5 works out perfect. And you just use the coefficients, so you just write a minus 2 and a minus 5 here. All right. Now, you are not finished with the problem. You have finished half of it. Well, almost half of it. Here, with the zero product rule, it's fairly easy to see that, well, let's write it out, that if this equation is true, the x minus 2 equals 0, or the x minus 5 equals 0. But at your level, most students skip that step and just look at this and say they can see that 2 minus 2 is 0, and 0 times anything is 0, so they just jump straight to x equals 2. And that's what I do as well. Alright, now remember, our goal was defined. Our suspicion is that this line intersects this parabola. It may intersect it at one point, but now that we have two x coordinates, we know for certain that our line is intersecting that parabola in two places. So we know that we have an x coordinate for each of these points, and we have to find the corresponding y-coordinate. Well, the second equation is an easy way to determine y. Given any, if you're a point on this line, then you satisfy this equation. So if x is 2, 2 minus 2 is 0, and that's our corresponding y-coordinate that we have this line intersecting this parabola at the point 2, 2. Well, look here, you've got x is 5, so 5 minus 2, and you have the 5, 3. So you had one point, and we give the x, y as the order, and they refer to that as an ordered pair. So we have one point, and we have a second point, and those are our two answers for this. Alright, so I hope that helped. I'm going to make some more, pick two problems and some more similar problems of this from that quiz. So study this and ask any questions if you need to. Hope this helps.